Well, um, during 3, 4, maybe half years, we research Node.js infrastructure, and I would like to share with you some vulnerabilities we detect in this platform. I think there will be a few interesting things. We will discuss shortly architecture of Node.js, and I will perform two demos, how architecture of Node.js can be exploited by attacker and which damage can be applied on victim infrastructure or victim application. First, let's take a brief view on architecture of Node.js. Node.js is a single-thread application infrastructure that driven by event loop, and each event come to event queue and handled by event loop one by one. In case event received in the queue should be taken care by file system, database, or network, it's moved there and handled by this. It's applied by a callback function. After it, if a new event should be applied, it's come to the queue, and so on. In case some calculation procedure should be applied, it will be done by event loop handler itself. So we can present it in a human readable way, like you see in this slide. We have a cacher that receives the order from the customers one by one and transfer it to events handler. Events handler can provide some mission to others, database, file system, or network, or take it care by himself. This approach has few advantage and disadvantage. On positive side, we can see that in case of working with input-output incentive operation with database query or application, it's very efficient one, but CPU intensive operation is very slow because of a single thread implementation. And we will see it right now on the demo. Let's assume we have the source code presented right here. Я прошу оператора направить на экран, потому что это важнее. А это другое? Добро. In this source code, we can find out that the system received input and count all numbers that came from 1 up to p. If I will apply any input through the URL, by this way, I can provide input, for example, number 5, I see 15, I receive result immediately, 8, I receive 36. It's very, very quick working. But let's assume I have two browsers, and in the second one, I will provide a very long input. While it's working, I will provide 5 in second window, and you can see that while the first window no finish and no provide answer, the second one will be stopped. Finish the big number is finished. The second one is working well. By this approach, attacker can perform denial of service of your application if no check of influencing input on this calculation operation into a for cycle while will not be applied. So please take this in consideration while you implement your application. Second, I would like to discuss with you weak cryptography. Again, during research of Node.js infrastructure, We found any open source project over internet, and in this project we detect function that used for authentication mechanism and generation of new password. The code, we hide part of the code, but other is available for you, and we can see the logic is the following. In order to produce or generate new password for the customer, for user, sorry, we apply mass random operation, bring converted to string, and apply MD5 mechanism. In this line, we have two problems. Can you help me which problem we have in this line where my mouse is? Two problems? Right, MD5 and random. Absolutely right. MD5 mechanism known as a very weak one because we have user and tables, not new for you. Random mechanism is pseudo-random because of the following. The random mechanism is based on V8 engine, and here work as following. First, the system is start up. System is generate seed number that based on a timestamp of current time where system established, and after request of first random, system go to state number 0 and generate float number pretty long. This float number is separated into two parts. Parts one going to produce random 0 that come back to the function. The second one is produced state number 1 that can be derived to random number 1 and state number 2 and following. By this approach, the system can go and produce new random numbers. But the problem that Israeli researcher Amir Klein a few 2-3 years ago detect that this algorithm is breakable. You cannot compute from any random number his state, but if you have 3 states computable, you can calculate state number 4 and so forward. He provided this information to Google because Chrome uses this engine for random mechanism, but in browser, each tab has its own state 0. So in fact, it's a problem, but this problem for any specific application that use tabs. In Node.js, it's much more complicated and much more dangerous because single-thread approach, I explained from the beginning, I am able to calculate any random number for any application. So let's see how we can break this algorithm. We currently see our code that I presented before. In fact, I need to provide a reverse engineering on this technicality. Let's assume when mail.ru, I have a password in mail.ru, and I would like password of Taras. I can provide myself 3 times as forget password, forget password, forget password. I receive 3 new passwords. From this point, ladies and gentlemen, I'm able to predict the new one. So in our case, I have a little bit more complicated because of MD5. So if I will use a rainbow table and I will reverse a hash number to clear one, I will receive state. I have 3 states. I can take state number 4, and I am in. In fact, what I'm going to do, I will work with any Node.js application, will register with a user, fake user 1, fake user 2, fake user 3. After it, I will apply MD5 mechanism. We will receive clear passwords, And by same technicality that used to calculate state number 4, I will use algorithm and will take password of user. Let's do it. I have an application. It's very secured. It's with lock, and this provide me a real powerful mechanism to protect myself. First, I will go as fake user number 1, and I will register it on the system like I forgot my password. As a result, system provide me a password with MD5 and random mal. The brute force server is located in Israel, and because it's a very, very big table, about 200 gigabyte, I receive first state 0 number. Now I will register it as a fake user number 2, and the system provide me a control copy, control V. I can go back. It's applied. Yeah, now it's okay. And fake user number 3. I get third number, control copy, control V. Now I can write the series again. It's going too far away to perform calculation. Meanwhile, I can go as a real user and use a real and register. The password should be F8. F8. It's up and running. When we meet the customers and we scan source code with static analysis tool and detect this type of vulnerabilities, normally we receive answer, listen, it's not serious, it's not big deal. Gentlemen, it's a big deal, and take it in consideration. That's all. Thank you very much. Any question? I'm available.
Can you show us source code of register function?
You mean?
Yep. So not HTML one, but so inside it make it takes random and
okay, understood you. In fact, what we are doing, it's exactly what we declare. Just a second. Exactly what I declared before.
Oh, okay.
It's absolutely same. I just implemented MD5 to string MD5 random.
So do you know what is a way to and how to make web applications more secure when we use Node.js and try to implement such functionality? So what we should do to protect our?
I prepare myself to this question. In fact,
not to use Node.js.
No, I understand you. Look, for each language, for each technology, you should found real secured numbers for randomity. For example, you can use for Windows platform this method. If your application working with a Linux password, use this method. We in our application use an SHA most advanced algorithm with a few encryption additionally too. But this pseudo-random number is not serious one if you really would like to protect yourself.
So simply avoid a simple implementation of random algorithm in libraries called Maister, and use special random generators for.
You can use salt, for example, much more sophisticated.
Okay. Any questions?
Вы по-русски можете спросить.
Да?
Можно, да.
Критично ли вызвать 3 раза подряд эту функцию? То есть нам надо знать 3 подряд числа сгенерированных, или если я знаю первое, второе, четвертое, тоже сработает?
Я перейду на английский. Ваш вопрос, потом отвечу вам. The question was if I know any 3 state number, is it possible to predict the number 4? No, you should know 3 succession numbers, but it's very easy to use if I use script functionality. So, for example, system working hours, and I currently on state number 25,000. But if I will send 3 requests, I'm able to predict the new one.
Ну, то есть, получается, в принципе, можно избавиться от этого, не уязвимости, а, не знаю. Ну, хорошо, от этой уязвимости просто в коде функции register, еще раз вызвав generate next number. То есть, получается, один мы используем для пользователя, а один просто случайно генерируем, он убивается.
Но
никто его никогда не узнает. Ну, 3 никто не получит подряд.
In fact, I can send you list of requests, and I can receive a list of results. So this approach is problematical one, and any attempt to avoid it in wrong algorithm will bring us to break it. It's problematic approach.
Спасибо.
Mm-hmm.
What about the first one? When you brute forced MD5, the page also loaded for a long time, but it didn't produce DOS. What's the difference in approach? Why this loop made DOS, and why the brute force of MD5 didn't make a DOS? So how to mitigate the first vulnerability?
In case of V8 engine, the float number is generated is very long, but algorithm separate this number. Just take a look on my screen. Very good question, by the way. Take a look on the. Okay, take a look on the screen. This is a new generated password. This is state number 4. This float number was separated. Just part of it went to be a user password. Other part go to new state. By this approach, very short part allowed me to create a rainbow table that just 200 gigabyte of memory. It's pretty small. It will take about a minute to brute force it. By the way, if it will be extended and all of this number will go to the password, a rainbow table will not be efficient.
Well, but I mean, at the time when this page is working, when you press the start button, can you, will the application work in other browser window? So is it asynchronous or it works in the same thread? I mean, when you launched the loop, big loop, you couldn't load the page in other browser. And here you could.
I just pay you attention. I use absolutely two different tabs. I can use two different browsers.
Yeah, I see. But
It's no problem. I can absolutely separate.
so there is, I mean, what's the mitigation for the first one when there is a loop? How the coder must implement the loop if he needs one in order to make it asynchronous, not to DOS an app. So that if someone plugs in a huge number in that loop, application will not go down and will continue work. Maybe it's unclear.
Я не понимаю вопрос. Спросите по-русски.
Смотрите, когда вы запустили большой цикл, предложение
какой
зависло,
большой?
правильно?
Да. Окей, вы спрашиваете про первое предложение? Окей.
Да, я про первую
Окей.
уязвимость.
Окей.
Вы
got it.
запустили большой цикл, оно зависло.
Got
А
it.
здесь вы запустили большой перебор, и оно не зависло. Ну, не перебор, но все равно страница некоторое время грузилась при брутфорсе MD5, а при этом вы параллельно могли регаться.
Got it. In this example, both of them up and running on my one single machine. So it's based on Node.js, and while it's working, and this is computing procedure, it's take all 100% of resources and stock another one. In this application, it's two different services. One of them go to Tel Aviv for brute forcing. The second one is run on my machine. I have application in background, and it's a calculation performed on different machines. It's asynchronic, yeah. If I come back to my presentation, we just need to take into consideration that if you would like, if your web application mostly work with UI, take this advantage. But be aware with the fact, if you have a lot of CPU computation, it's very expensive.
Hi. At first, sorry for my bad pronunciation, but
Можно по-русски.
Yeah, and something. Can you tell us a little bit more about V8 random generator engine and in which product it has been implemented? We already listened about Google Chrome, maybe other browsers, and maybe it has implemented at operating system level.
Okay, I have not deep knowledge about it. I just can come back to my recommendation I provided previously. Just we need to take, and by the way, your question is very relevant for different platforms. So even for mobile platforms like iOS and Android, you should go to the documentation and read about a real random function and not pseudo one. It's the very same approach to PHP, to Java, to C# and so on. And second issue, you should understand how number you generate really should be randomized one. So if it's just simple game that not make sense, you can use mass random approach. If you are going to for registration and password, you should take something seriously. To use salt, for example, to add to the number and so on. But I can't provide you name of the function for specific language or platform.
Okay, and maybe a little bit deeper. As I think that random generator is implemented in deep level of operating system. For example, in Linux, it's defi random. Doesn't this vulnerability in operating system level or just in browser implementation of this algorithm?
V8 is engine that used by Chrome. And the same engine is used by Node.js as well. So I can be sure that in both of them, this algorithm, if you're using both of them in Chrome or in Node.js, is problematic one. If you are going to other platform and they're not use V8 algorithm, it should be okay.
Okay, thank you.